Assalamu alaikum. This is a problem solving session 3 this semester. We address inheritance, abstraction, and interfaces. Go directly to the topic. Inheritance. Inheritance is used when you have some classes, and there are classes with similarities, but you don't need to write the code from scratch. And this is essential in object-oriented programming. For example, airport taxi is a taxi, but it charges more than regular taxi. And we will solve this example like we have a class taxi, and we will inherit all the taxi features in what we call airport taxi. But before we start, let's talk about a person. A regular person have a name and age. However, our student is a person, but there are more information that are needed for a student, like student ID, GPA, college, and many other things. I am also a person, but I'm not a student. I'm a faculty member. And there are other things that are usually needed or attributes needed for a faculty member, like college, department, office number, rank, specialty, and all these things. We will start with a simple example, which is a person. Here you see a person class, very simple class, only name and age. And we have a constructor that takes name and age, set and get name and age, and return a string. That's it. This is our person. We can write quickly a tester for this person. Okay, tester with a main class. And here we can say, for example, in the same package, person P1 equals new person. And in the constructor, as you see, we need name and age. This is Muhammad Ali, for example, and his age is 20. If you go back to the person class, you see I added toString. toString is inherited from the object class. And when you print a person now, when you just call sysout, print a person object, the toString method will be called. So now I'll just output the person here. I will output the person P1. So we make sure it's working fine. Here we run the person and name Muhammad Ali, age 20. And this output's coming from the toString method here in the person class. Definitely you can change or set any other attribute like p1.setAge. Okay, I'm changing the age to 33 and outputting the same person again. And now we see that we have only two attributes, name and age. However, I want to create a student class. The student has a name and age. But the student has also email address, for example, GPA, college. In this case, we do not reuse or rewrite the code from scratch. We inherit all the features of the person class in our student class and add only the new things that are not available in the person. For example, a student has a email and GPA. So in this case, we write a class that inherits everything in the person. The person in this case is called superclass, and student will be called subclass, in which you inherit all the features of the superclass and you add more things to it. Let's create a student class in the same folder here, a new class. I will call it student. And still, student has no relationship at this moment to the person class. For example, the student has private string email and private double GPA. So these are the two things that are needed in the student in addition to all the things that are available in the person. In this case, what you do, you inherit everything from the person class using the extends keyword. Extends person means you will use all the features in the person class, all attributes and methods. Extends person. In this case, student is a subclass, person is a superclass. You will see an error message here. We will fix it now. Before I fix the error message, you can also create your own setters and getters for all the new attributes of the subclass. We did this for email and GPA. Next, constructors are not inherited. So a student is a subclass of person. Everything in the person class is inherited. All the methods here, anything that is non-private is inherited. However, you must call the constructor of person. Remember now, the student is going to have 4 things, not 2 things. Name and age, plus GPA and email. So in the subclass, you must call the constructor of the superclass. You call it with the attributes that are inherited from the superclass. For example, in our student class, we're gonna call the constructor of the superclass with name and age. So let's see this. I'll go to the student class. You can ask Eclipse to do it for you. Here, Eclipse tells you that implicit superconstructor person is undefined. Oh, since the superclass person has no default constructor, then you must call the constructor in the superclass. Otherwise, this is not gonna work. In this case, you can ask Eclipse to do it. And see here what happened. Eclipse did the minimum for you. You have a student with name and age exactly like superclass. Super name age. Here you are calling the superclass with name and age. And the superclass will do all the setters and getters and all the validations there. No need to duplicate the code and add the code there. However, since this is a student, I can add here, for example, I can add email, which is a string, email, and double, which is what? GPA. And I need maybe to take these 2 things before the first constructor. Fine. So far, when I create a student, I will call it with 4 attributes. 2 are inherited from the superclass and 2 are only available in the subclass. The first statement in the constructor of a subclass must be calling the superclass with the attributes inherited from the superclass. Then you can do this set email is equal to email and this dot GPA is equal to GPA. So the first statement in the constructor of a student is calling the superclass, which is here person, with the attributes inherited from the superclass. Look at the constructor. The only constructor of the superclass is this one. So we must call it with the name and age, and the superclass will do all the code for you. So now, my student has a constructor. The constructor takes 4 things. 2 are inherited from the superclass and 2 belongs only to the student. So the constructor of the superclass here, the constructor of the superclass must be called the first statement in the subclass. Hopefully that answered your question. Now, student is a class. You can create a new student, and let us create a new student here. Student S1 equals new student. Remember, the constructor of a student now takes 4 attributes. Email is also one of them. Ali at. And finally, GBA, which is a double. This is our first student. So when you create it, the 4 attributes here, look at the constructor, name and age are handled by the superclass, which is very useful here. And email and GBA are handled locally here. So this is our student class. We still need to do something. If you try to print a student, for example, S1, when you try to print the object, the toString method of the object is used. However, here in this example, we do not have a toString method in the student class. So no toString method. The question is there a toString method in the superclass? Yes or no? If yes, then the toString method of the superclass will be used. Look at this now. What happens when we run? When we run the code here, name Ali Hassan, age. However, I do not see the GBA, I do not see the email, simply because you did not do anything to handle them. You inherit all the methods from the superclass, and you are still using the toString method of the superclass. طيب, what if you want to change the way you use a method from a superclass? This is called method override. And this is typically used in object-oriented programming and inheritance. طيب, let's look again at the output. You still get the same output here for a student or a person. طيب, what do you want to add? I want to add only the email and the GBA. So is the thing in the superclass is still valid? Yes, it is still valid, but I just want to add it. Perfect. In this case, you need to override. In this case, you need to override the toString method of the superclass. Override means change the way it works. You do not have to write it again from scratch. Change the method it works. You need just to use override. Let me go to the student and show you how we could do this. First, you need to use override. In this case, you tell the compiler that I am overriding this method. Override means the method is available in one of my superclasses. The method is available in one of my superclasses. So here we can come and just let me see here. This is override, guys. Okay, here is a student class and I am overriding. The method will be the same name, same return type. Same thing here. Type. A very important question now and very core concept. What do you want to override? Do you still need the code that gives you the name and age, or you need to write it again here? If you need to write it again, this is not the right choice. If it's usable. So what the answer to this question, I need everything from the toString of the superclass, which is name and age, plus I need to also add the email and GPA. Good. So in this case, we would say return super. Super in a subclass. Super means you are referring to something in the superclass, not in this class. So when you say super toString, give me everything from my super class, which is person, plus I need to add to it, like, for example, GPA and email. This dot get GPA and plus email, for example, here. Email plus this equal get email. So now let me explain this method again. I want to reuse everything from my super class, so you will get everything from there. No need to rewrite the code. Plus, I want the GPA from here and here and here. Now, if you go to the tester and you try to print a person, the toString method of the person will be called. If you try to print a student, the toString method of the student will work. So let us see this one here. Run. Look at the output now. We see name, age. All this output is in, we did not write code in the student for this one. We just reused it from the super class. And here we have our GPA and email added or extended in the subclass. Of course, yeah, you can format, you can change the format. This is a topic that we covered long time ago, changing the format of the output. Here we are addressing how to reuse code from the super class. The super class toString will return a string. Do whatever you want with that string. For example, do whatever you want. You can do whatever you want. For example, see, you want, for example, to uppercase. You want the output of the super class to be in uppercase, for example. You do whatever you want in the output coming from the screen. You see this here? We say to upper or any other way. The point is, in the super class, you can reuse everything from, in the subclass, sorry, you can use everything from the super class and add to it. No need to write it again from scratch. With another example, this will be clear. I will create another one here, another class called faculty. The faculty, let us say, has what? For example, private string college, private string phone number, private string integer office number, and this is a faculty. And private, this is a lot, private string rank, for example. However, faculties still has a name and has an age and all these things. Type, we will do the same thing. I can do setter and getter now, generate setters and getters for everything if I want. Validation is not our topic today. Now I can say extend person. Once you say extend person, you need to add what now? The constructor. You must call the super class with the attributes of the super class in the only constructor available there. If you have multiple constructors in the super class, you can call any of them. So now let me just do here things, college. Okay, string college. So faculty has many things, like not only email and GPA, and another one string phone. For to save time, I will just remove rank, and I will remove rank and office number. You can add as many ones as you want. So now here, I can say this dot college is equal to college, and this dot phone is equal to phone. That's it. Again, you can go and create a faculty here. Faculty. F1 equals new faculty, and same thing, faculty name and age, and next will be college, engineering, and finally phone number, which is going to be a phone number. You still now, when you output the faculty, if you want to print it, F1, you still will call the toString method of the person. Look at the faculty, because the faculty, it does not override the method from the superclass. If you don't have a toString, it will call the one in the superclass. I will do the same thing that I did to the student in the faculty. I will just copy paste the code here. I will go here now, override it. So now here I can say college. Okay, college equals this dot get college and phone number, this dot get college, and finally phone here I can say this dot get phone. So now if you try to print a faculty, and I want you here to pay attention, see, get phone is available in the faculty class. Get name is inherited from the person class. Get college is available in the faculty class. Get age is inherited from the person class. So you have all the methods in the superclass available to you. Now, I added a toString method. If I go to my tester now and run the tester here, you see I get the faculty toString, I get the student toString, I get the person toString. If you want to add an employee and put his salary and department and date of hire, you can do it. I can do something simple here to the student. See, I can say here, for example, return student, then plus, look at the output now. So you will write student, then the name. For faculty, I can write here what? I can write faculty and plus. So it will write the word faculty, then whatever you get from the superclass, then college. Let us just do this thing and do it there. See, student, then name and age, then the remaining attributes from the class, faculty, and so on. The good thing about inheritance, you don't have to repeat the code, and everything is available to you in superclass. If it's non-private, then it's usable in the subclass. So many examples can work with inheritance, but I need here to tell you one important thing, that student is a person, faculty is a person, student is a person, and faculty is a person. You can put an array of persons, see here, I'm creating an array of person, and I will call it persons. New person. It could be an array or array string, and the size is 3. This is an array of persons, and the size is 3. Can I put students, persons inside it? Definitely. Persons 0 is equal to P1. Can I put student inside it? Definitely. Student is a person, or at least everything in the student is person plus something else. So here I can say persons 1 is equal to S1, which is a student instance, and finally I can say persons 2 is equal to faculty. All of them are persons. Any child in the hierarchy is considered a person. Even here I can use enhanced for loop for person P in the array persons. I just need to output it here, sysout P. This is the enhanced for loop we learned long time ago. Let us see the second output. See, this output is coming from our for loop. If you want to make sure that this output is coming from our for loop, let me just comment any other sysout. So now, persons or any of its subclasses you can put in an array of persons. Here is the output that's coming from the person array. Let me just here, I need just to do this thing. Inheritance is a big topic, and what you need to know is that you can reuse everything in the subclass. And here is another example. You order a taxi, they charge you by kilometer. We always try to simplify examples to make explanation easier. They charge you by kilometers. For example, let us say 5 riyals by kilometer. So this is a regular taxi. But when you order an airport taxi, they calculate it in a different way. Let us see that, for example. Here is a taxi. The regular taxi needs only distance and passengers. The distance and passengers. And the way they calculate the charge is like by multiplying the distance with a number like 5 riyals, 10 riyals, or so many. However, airport taxi is different. For example, they charge you extra money for the number of luggages. How many luggages? And their meter does not start from 0 or 5. Maybe the airport taxi meter will start from 18 or 25 or. So airport van is a taxi, but the way they calculate the charge is totally different. And they still need to know the kilometers, they still need to know the passengers, but they need also to know the number of luggages. So if you have a class called taxi trip, and you need to write a class called airport van taxi, you just inherit or extend it. If we go to this here, for example, let us see a class we did in a previous example here. Okay. And airport taxi. I cannot find it. Let me see where I put it. I know I did it, but Yami, I don't see airport van. So what you need to add in the subclass is like something related to extending. Let me see, maybe here, yeah, here. Okay, look at this code. Public class taxi trip, distance and passengers. You don't care about anything else. Distance and passengers. Get distance, set distance, and now the most important thing is get trip charge. Look at this. The trip charge is multiplying the number of kilometers by 4.5 riyals. Bas khalas, that's it. And the toString here is formatted. You get the distance and you get the passengers and you get the number of charge. So in the toString, you call these things. Let me test the taxi trip. Look at this. Taxi trip TT1 equals new taxi trip 10, which is the number of kilometers, and 2 persons. You can calculate the charges or Brent calculate the charges, but if you call the toString method, it will call all those methods and put it in a report. Let me show you the output and then you can see it. Trip detail. This is from our toString method. Distance, 10 kilometers. Passengers, 2. charge is equal to 45. Now I need to do this in a different way for airport van. The airport van or airport taxi van or airport trip, they calculate it in a different way. They have starting meter and they have they multiply each luggage by 5 riyals. So you still like everything in the taxi trip class, but the only thing that you need to change is the way you calculate the trip charge. In this case, you reuse all the code by extending the class, but you still need to override the get trip charge. How to do this? Let's see this now. The only extra thing here I need is what? Is luggage count. The only extra thing I need here is luggage count. Right. If you extend taxi trip, then you must call a constructor from the taxi trip. In that constructor, look at the taxi trip, you must call this constructor and provide it with distance and passengers. So in this one now, you still need to do the constructor. I will need only to add one thing to it, which is integer luggage. Integer luggage. So I called the super class the first thing. Then I said this dot luggage count is equal, for example, to this dot luggage count is equal to luggage. That's it now. The only new attribute is the luggage count. And our constructor is ready. However, now there is an important way. The way we calculate the charge. Look here. The way you calculate it here is only multiplying distance with 4.5. But as a taxi, airport taxi, you will not do it this way. You will put a starting meter, let us say 20 riyals, plus 4.5 for each kilometer, plus 5 riyals for each luggage. Yani, in other words, you need to override the get trip charge. In the subclass, you need to override the get trip charge. So if I go to this one, I need to use, for example, override. I will just remove this now. Override, you are telling the compiler, I am overriding a method from my super class. So I told you that it's like 20 riyals plus 4.5 times kilometers. I can say return 20 riyals, good, plus what? Super get trip charge. What is super get trip charge? How much you charge in the super class, which is taxi trip. I still need it because I'm going to charge you also 4.5 per kilometer. Plus this dot get luggage count. I know how many luggages times 5. So look at the way we calculate the trip charge. The meter like that is going to open on 20 plus 4.5 for each kilometer, which is inherited from the super class, plus 5 riyals for each luggage. That's it. That's it. So now here you reuse the code from the super class and add your details in the subclass to it. One more thing. Let me show you here how things work in the tester, test taxi. See, the output is a nice output. Okay, it's a nice output. However, what is missing here? What's missing is the number of luggage, صح? What's missing is the number of luggage and maybe other details. So isn't it a good idea to reuse this output from the super class and apply it in the subclass? So what I'm going to do in the airport van trip is what you saw previously with faculty and student. And see here, I say return, I override the toString from my superclass. I say airport trip luggage count, this dot get luggage count, whatever, a new line plus super toString. So plus super toString means what? I am reusing everything from my super class. I am reusing everything, all the output from the super class is used, plus only the luggage count. So let me now show you the airport van trip. When I create airport van trip, which is a subclass, airport van trip equals new airport van trip, and I need to know the kilometers, 10 kilometers, 2 passengers and 4 luggages. So this way will be, since it's a subclass, it's an instance of a airport van trip. If I output it now, AVT, you will see that anything that is inherited, see now the toString is called from the subclass, and the trip details and all these things are called from the superclass. And look at the charges, 85. It's the same distance, but the charge now is different. Next topic is abstract classes. Abstract classes is compulsory inheritance. Yani you don't have a choice. Abstract class is usually a class with abstract methods. What does that mean? It means you cannot create anything from it. You have no choice. You must subclass it. You must extend it. Look at the employee example here. The employee is abstract class. How do you know it's abstract class? In the class diagram, if you see anything italics, ma'il, then you know it's abstract. It has one thing which is year-to-date earnings, how much money he made from the beginning of the year. However, we have an abstract method, compute pay. How do you know it's abstract? Look at the method. Is it written in italics? Yes. طيب, abstract class, you cannot create anything from it. Abstract classes have methods. Some of them, of the methods, are empty. We call those methods abstract methods. You cannot reuse them. You must override them in the subclasses. You cannot create an object from an abstract class. You must subclass it. Now, here in this example, employee is an abstract class. It has one abstract method, which is compute pay. If you want to create an employee, you cannot. You must extend it by subclassing it. For example, here, full-time employee extends employee. Tamam. Then, in the full-time employee, you must implement all the abstract methods of the superclass. Again, we have another employee, which is part-time employee, extends employee. In order to be able to create an employee, you must implement all the abstract methods in the superclass. The methods in the superclass can be, some of them can be abstract, some of them can be normal. You can reuse the normal. However, if the methods are abstract, then you must implement them in the subclass. This is not a choice. This way, we can say with abstract classes, implementing the inheritance is compulsory. You cannot create a subclass of employee unless you implement what? All the abstract methods of the superclass. This way is, or this concept is to enforce unified design. Look at this simple example. Animal. Animal, the class is abstract. Look here, you see the word what? Abstract. It has two methods. Pay attention, please, here. One method is abstract, which is animal sound. You see here, you see a semicolon. The other method, which is a sleep, is non-abstract. So you can use it directly from the subclass. Can you create an animal? No, you cannot, because animal is what? Abstract. You must extend it. What else? You must implement all the abstract methods in the subclass. Look here, cat. Cat extends what? Animal. In order for a cat to work, you must provide your own implementation for the animal sound. For a sleep, it's optional, but for animal sound, you must do it. So now, cat extends animal, perfect. See here, you must implement what? Animal sound. But sleep, you inherit it. You can use it directly from the superclass, like regular inheritance. But if the method is abstract, it's not a choice. You must implement it. See the example here? We say cat, new cat, cat, animal sound. Of course, it will call the animal sound here from the implementation of the subclass. And sleep, in the cat class, we did not override the sleep method of the superclass. So it will call the sleep method of the superclass. So the output here will be as you would expect. Next, this is another example. Shape. Shape is an abstract class. Shape is an abstract class. Can you create a new shape? No. Why? Because the class is abstract. How many methods is there? One method. Is it abstract? Yes. What is the method name? Draw. طيب, how can I create a shape? تمام. You must extend it. طب, how to extend the abstract class? You must provide your own implementation for all the abstract methods in the abstract class. So here, rectangle extends shape, draw. They do whatever you want. Circle extends shape, you must implement the draw in both of them. So now, you will know that any subclass of shape must have a draw method, because you cannot be a subclass of shape unless you implement the draw method. So if you create a rectangle or a circle, you know they both have a draw method, and each of them has its own implementation of that method. Look at this example, very useful example. I have already solved these examples in my previous video. You can watch them. Public abstract class shape. This is abstract. Get area and get name. Excellent. Both are also what? Abstract. Now, rectangle is a shape. What do you need for a rectangle? You must extend the superclass. You cannot do like this. You cannot say shape my object equals new shape, because shape is abstract class. طيب, تمام. I need to create a rectangle. For a rectangle, guys, what do you need? I need width and height. Provide them. Good. If you extend shape, great. If you extend shape, then you must do what? You must override all the methods of the shape. شوفوا, see here, for a rectangle, what is the area? Width times height. What is the name? Rectangle. So now, for a rectangle which extends shape, it must implement all the abstract methods of the superclass. So if you are a subclass of shape, then I know you have definitely implemented get area and get name. Otherwise, the code will not compile. See the same example again. Circle. Circle extends shape. This is a circle. What do you need for a circle? You don't need width and length. What you need is what? Radius. بس خلاص. طيب, to be a subclass of shape, what do you need? Oh, I need the implement the area. This is how you calculate the area, right? And get name. So you must implement all the subclasses of all the abstract methods of the superclass. So now, if I look at any subclass of shape, I know it has a method called getArea and another method called getName. Otherwise, the code will not compile. This way, you make it uniformly compulsory implementation of your code. All of them must follow the rules of the abstract class. All subclasses must implement the getArea and getName. Does that make sense? We will go to interfaces now. Interfaces are a different way of inheritance. With abstract classes, some methods can be abstract, some methods are not. But with interfaces, all the methods are abstract. However, this is not 1,000,000% true. In the last few years, this has changed. But let us stick to the historical thing. The difference between abstract class and interface, the first difference is that interface, all the methods of the interface are abstract. Or we don't call them abstract, they are empty. You must implement them. But in the abstract classes, maybe you have 10 methods. 6 of them are abstract, 4 of them are not. So any subclass must only implement the abstract methods of the superclass. But for interface, all the methods are abstract. Another very important difference between interfaces and abstract classes. Abstract classes are used usually when the classes you create, like rectangle, circle, triangle, whatever, they are related. Yani all of them are shapes. Related in inheritance. All of them have getArea, so many common things. However, interfaces can be used with classes that has no relationship. Look at this example here, for example. A finance company or system, you have employee and invoice. Invoice means fatura, okay? يعني شيء راح تدفعه. Employee is not related to the invoice in inheritance. However, for you as an accountant, let us say, you must pay the employee and you must pay the invoice. This is very limited similarity between them. They are not related in inheritance. Employee has a name, has a date of birth, while invoice is something else. But both are what? Both are payable. This is the second difference. First difference, in interfaces, all the methods are abstract. In abstract classes, no. In interfaces, usually are used by classes that has no relationship or inheritance relationship. Abstract classes usually do. This is an example. Look at this, ya shabab, banat, guys. This is an interface, public interface payable. This is an interface called what? Payable. How many methods are there in the interface? One method. What is it? What is the method? Get payment amount. Only one method in the interface. طيب. We have a class called employee. Oh, with interfaces now, I want you all to know that we do not use extend. If you are implements interface, the name of the interface is payable. So in your class, you would say implements interface. طيب, for an employee, what is the get payment amount? It's his salary, right? Remember, guys, employee has a name, has a date of birth, has a department, has allowances, has so many things. But one thing that is common between employee and bills, both must be paid. So now, implements payable.
implements payable, it means the employee class implements the payable interface. ايش يعني implements the payable interface? It means it provides an implementation of all the methods in the interface, which is one method here in our simple example. طيب, see the second one now, which is invoice. Invoice implements payable again. The invoice, for example, you have a company, how much money, what is the invoice, what did we buy from them, why we need to pay, so many things. But one of the things is the payment amount. And because the invoice implements payable, then the invoice also must implement all the methods in the interface. So actually, there is no tashabuh or similarity between employee and invoice, but both of them must be paid. So now, do you see that the only method in the interface, which is get payment amount, is implemented in the invoice and employee? I created this code before to save time. Hopefully we can get it quickly here and here. Look يا شباب بنات, look here. This is your interface. Look at it. Very simple. Public interface payable. One method. So whatever class you make, like employee, what you need to provide here? Implements what? Payable. You don't have to use constructor. You can use everything, so many things. But there is only one thing you must do, which is what? Implement the method of the payable interface. Right? What's the method of the payable interface? Get payment amount. Best. Look at the invoice here. Invoice has total bills, company name, phone, so many things. Fine. But now you see override. When you see override, you know this thing I am overriding either. It's either you are overriding from a superclass or an abstract class or an interface. So get payment amount is also inherited from there. Let us see if we have another example here. This is another example. Look at it. Animal interface, animal sound, one method. Sleep, another method. So how many methods we have in our interface? Two methods. Now, any class that implements the interface must provide its own implementation for the two methods, animal sound and sleep. Otherwise, the code would not compile. Look at this, cat. Class cat implements animal. Implements animal means what for me? That you have your own animal sound and your own sleep. So here, this cat meow meow, Brent, whatever. Look at this code again. Class dog implements animal. So the dog must also provide its own implementation of animal sound method and sleep method. So now you can say cat and dog are both animals, which means life, which means what? Cats and dog both implements the animal interface. Implements the animal interface means what? That all the methods in the animal interface are implemented in the subclasses. Look at the output now. Cat, my cat, new cat, cat animal sound. Of course, cat animal sound will call this method. Cat sleep will call this method. Then you create a dog here. Animal sound, you create the dog method. And sleep, you call the dog method of sleep. Look at this one. Public class car implements transporter. طيب, what is the transporter? I need to know the interface first. Okay, look at this one. Transport, public car, public void drive. So do you think that the transporter has a method called what? The method called what? Move. There is only one method in it, which is what? Move. If you do not implement it, If you do not override the move, then this will not work. Let me show you another method here. This is the car. Implements which interface? Transporter. The transporter has a method called move. You must implement it. Look at this code. Bike implements transporter. You can do whatever you want, no problem, but you must implement the only method that is available where? In the interface. See now, both car and bike, they both implement move. Does that make sense? Okay, I will do my final code here. I will just show you that something that, okay, look at this shape. I have shown you this code, shape, and I have a 2D shape. 2D shape, I will do shape here. What is shape? Shape is an abstract class. Tamam. Okay. Circle is extends shape. I'm gonna make some changes to the code to save few minutes. Tamam. Okay. Look at this code. You have a shape. I will show you shape. What is a shape? Is the class abstract? Yes. What do you have? Get name and what? Get area. That's it. And you have a toString. The toString is not abstract. If the toString is not abstract, then you have an option to either override it or use it directly. But you do not have an option with this one. Quickly, I will go to the circle. Circle extends what? Shape. What do you need for a shape? The only thing you need for a circle is radius. Look at this. Radius. Type. Now, there are two methods you must implement. What are they? I'm showing you the shape. Get name and get area. How to implement the get area of a circle, guys? I go to the circle, get area. Override. You all approve this. Hopefully you know what's this. The area of a circle. Tamam. Get name. This is a circle. You must return the name of the circle. Perfect. So now what I want to show you that the circle extended the abstract class shape. The abstract class shape has two methods, which is get name and get area, and the circle provides its own implementation. طيب. Can I do triangle? I want you to see triangle quickly. Here, triangle. Okay, triangle is a class. What do you need for a triangle? Oh, for a triangle, I need private, double, base, and I need private, double, height. These are the two things you need for what? For a triangle, right? However, you want to extend shape. Let me just first do the setter and getter quickly. Okay, hi. Now, your triangle extends shape. Since your triangle extends shape, you must implement all the abstract method in the superclass, which is shape. So what are the two methods? Get name and get area. Perfect. I'll go back to the triangle. Here, look, they will not let you go. Add unimplemented methods. I did here. See? Automatically Eclipse added them. طيب. What is the get name of the triangle? I will return triangle. Very easy. What is the get area of the triangle? Return this dot get base times this dot get height times 0.5. Is this the area of the triangle? Does that make sense? Now, the triangle implemented get name and get area. Type, what if it is a square? Very simple. What if it's a rectangle? Same thing. The rectangle needs what? Width and length. What about a square? Square needs only one side. Can you implement the get name and get area? Yes, everyone has its own way. طيب. Now, if I go to tester here, I just want to make simple changes. Here, circle, a new circle, and I will make a triangle. Okay, T1 equals a new triangle. and I will put any values. Does that make sense? Okay, hopefully I did not write it wrong. Triangle. Okay, let me just save everything. And triangle, somewhere is wrong here. Let's see what's error. Oh, I forgot the constructor in the triangle, صح? We were busy with other things. So my constructor is very simple here. Generate constructor, I only need base and height. Tamam. This is done, our base and height, that's it. So I go for the tester now, and our triangle hopefully is okay, is written, I believe is not written right. Okay, here is fine. Now let me just output both of them. Let me output the circle. Of course, it will call which methods? It will call the toString method. If you have a toString in the circle, let us see if we have a toString in the circle. Yes, we do. Oh, see the circle, what they did. They reused the string from the shape and they added the radius. I will steal this from here. I will go to the triangle. I will post this here. And I will use everything from the superclass. But for a triangle, I need to provide base and height. صح ولا لا? Right. This dot get base plus height, and this dot get height. So this is the difference between what? Here I can say, okay, height and plus this dot get height. So now, if I run the code again, the tester, it will call the toString of the circle. Okay, let me just run it now. Here, tester. Let me run the tester. I need to output also the triangle. If I output the triangle, it would call it from the T1. Tamam. So now I know both. See, triangle area, base, height. For the circle, it's only radius. The way the area is calculated inside the circle is different from the way area is calculated inside the triangle. But I know both are subclasses of shape. Then if both are subclasses of shape, I know both have two methods. Both have getName and getArea. If you create a square, it will take you 1 minute to do it. If you create anything else like this. One final example here, I need you to pay attention to. I will create an interface called, can we make the shape? This is our shape, square, circle. We need also, very important example here, we need our shape to implement an interface. Look at this. I have an interface, I will call what? Resizable. Resize for a circle is not like resize for a triangle. Is not a resize for a square. Resize can be shrink or grow. I created an interface called resizable. There is only one method in it, which is what? Resize. And it takes percentage. Now, I want all the shapes to be resizable. يعني, I want the circle, triangle, square, any shape. Do you do this in the class triangle and do it again in the circle and do it again in the square and do it again in the rectangle and do it there and there? Or why don't you make this in their superclass? Listen carefully. I will go to the superclass here, shape, implements resizable. Hopefully I wrote it right here, resizable. So my abstract class shape implements resizable. 2 minutes, I'll finish. Implements resizable means what? I am an abstract class. I have two abstract methods and I implement resizable. What's resizable? It's an interface. So now, look, now our code will not work. You will see errors. Why? Because circle extends shape and shape implements resizable. Triangle extends shape and shape implements resizable. In order to be able to do this, you must also implement all the methods of what? Implement all the method of the interface. How many methods are there in the interface? Only one method. What is it? Resize. So in any subclass of shape, since your superclass shape implements resizable, you must implement the resize method. See, now the error will go. See here. Look, ya banat, the error will go. See, I just need to make it public. Void, resize. And best thing is to do what? Override. So now, resize. See, no error now here. Why? Because your superclass implements resizable. What is shape here? Shape implements resizable. So you must, as a subclass, implement it. I'll go to triangle. I also need to provide one thing for the triangle. What is it? Again, which is what? Resize. I will show you how to implement the resize now in a new way. And I will finish in 2 minutes. This is resize. Guys, for the circle, resize, this is a percentage. This dot set radius is equal this dot get radius times percent. يعني ايش? Resizing a circle, if this is 0.8, it will multiply the radius by 0.8. So the circle is resized. If this is 2, it will multiply the radius with 2. I will go to the triangle. Resize. Resize for the triangle is different. We need to resize both base and height. So I could say this dot get height base, sorry, this dot get base is equal to this, sorry, this dot set base, sorry, set base is equal to this dot get base times percent. Good. And I will do the same thing. So now the height here, this dot set height is equal to this dot get height times percent. وبس خلاص. Now, if you send 0.8, the shape will be resized. If you send 2, the same shape will grow. If I save everything here, no errors. Tester, see now, look, ya Juan, circle now, the radius is 3. C dot resize, wow. Okay, 2. So we will multiply the size of the radius by 2. Let us see the rectangle. T1 dot resize 0.5. So the rectangle will be smaller by 50%. The circle will grow by 200%. How to implement it? It depends on the shape. Let me run this. Look at the radius here. Okay, I don't see the radius, but here see 2 and 3. Okay, the radius value was multiplied by 200. Oh, okay. Maybe radius here in the circle. Let me make sure this dot get radius and circle tester. Okay. Now, and I am done. I will stop recording, but I will